soon, and hopefully Lauren will join us. So, okay, let me pull up. So we're going to start the group quiz. Number 3, find the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25. So, I need to help you to scribble on this first part. Okay, so we're just going to plug this in, right? We know 90% is the z-score of 1.645. And, times 50, right, divided by the square root of 25, which is really 5. 5 divided by 50 is really 10. Yeah, let me turn my calculator too. This is 16.45. Oh wait, I didn't even look at that. Did I do that right? So we're just gonna go 50, right? We're just gonna plug it into that stand. Do I need to do a plus and a minus? Because surely.
No, I think 16.45 is the answer.
Okay. That's what I'm gonna put, because that's what I got, and that's what it seems like it should be. Okay, which of the following statements is true? The square of standard deviation is an I don't think that first one's right. U is a point estimator. I would say the third one.
Huh?
So is it the third answer that mu is a point estimator of?
No.
No, the sample is the point estimator of the mu.
Yeah, I think it's the second one.
Okay. Gina wants to construct a 95% confidence interval for GMAT scores. She knows that the standard deviation is 113. She collects a simple random sample of 64 and computes a standard deviation of, no, that'd be the mean. Is this information for the next 6 questions? What is the point estimate for the true GMAT score? The point estimate would be the 526, right?
Yes.
Okay. What is the margin of error for 95% confidence interval for the true GMAT score? So 95 is 1.960. And I have 13 divided by 64, which is what, 8? Square root of 8. Okay.
Hi.
Hello.
Have we started the quiz yet?
We did.
Okay, sounds good.
Yeah, we're on question 6 actually.
Okay, so Min, I got 27.685.
Yep, that's what I got too.
Okay.
Perfect.
Is Lauren here? Yeah?
No, she's not. So we just got started because Min's got to be off in 45 minutes.
Okay.
Another group class. Do you want us to kind of back up a little bit? Kind of just hit the highlights of 3 we just calculated using that simple formula. Because we decided that it was basically some formulas that we need to memorize, 3 z-scores, and we're just basically plugging in information. And that's about the accumulation of this lesson on top of a couple of rules. Anyways, we said X is the point of estimator of the population medium. So the second answer, number 4, we got 526 for question 5. 6, we got 27.685. We're on number 7 now. What is the lower limit of the confidence interval? Round, to 3 decimal places. Okay, so if that is the positive, right? Or is this when I z-score plus? This is my z-score, this is what I get. Okay, this is the part where I guess I'm just got confused because we have our x equals 526, right? And this is this our standard deviation right here? Or is this our
I think
confident interval right here?
I think it's like the standard deviation where we just use 526 minus 27.685, and I got 498.315.
So don't use the number above. We're just basically going back and doing
The minus.
okay.
I think.
I pulled up too far. So you just literally went 526
minus 27.685.
because that's the Z star, and that's what makes it different. Okay. And then you just did times the 113 divided by 8. Or you just did 526 minus 27.65.
Right. 0.68.
Okay, that makes more sense now.
And the same thing goes to question 8, where you just use 526 plus 27.685, and you get 553.685.
Okay, so 7 you put 498.315.
Yep.
Okay, and so then the 8, what is the upper limit? So then we just add 5.26 and we add that. So like 553. Okay. 0.685. Okay, what would happen to the width of the confidence interval if Gina increased the sample size? The width decreases, right?
Yeah, that's
If
what
you increase this, the margin decreases.
that's yeah.
Okay. What would happen to the width of the confidence interval if she changed it to 99%? It would increase, right? A wider confidence interval, so we'd have a wider, so it would increase.
Yeah.
Interval. Okay, the Bright Bulb Light Company is planning to study to access the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confident interval with a margin error of 50 hours. What sample size do they need? Okay, so this is when we need to do the n equals, so we need to solve for n. So n equals whatever our Z confidence score is, times, right, the mean divided by. Okay, so is this when we need to go and do is this when we basically found that first one? But how are you going to do that, Min?
I'm not sure about this actually. I think we can try like the one that you say.
I'm going to go back to the lesson and run back up. Okay, M equals Z. So M equals z star times the square root, or times the standard deviation over the square root of n, right? And basically come up, okay, how do we find m though? M equals, okay, so I think we still have to just go back and find out what z is first before we can plug it all in. So if we know this is 400, we know that 95% is 1.960. Divide it by the square root of 50, which should be 25. It should be really easy. So I have a z, well, I have a margin of error of 31.36.
How did you get that?
Okay, so I went back to the lesson, and when I look at it, to find, so I went back here and it said m equals z squared with our little division here of standard deviation. And so I know that z is that 1.960. So I plug that in there. I know that 50 is the number, so like the square root of that would be 5. And then I put 400 on top.
400, what was on the bottom, the square root?
The square root of 50 or 25.
Okay.
And then I times it by that z-score. And that's what my margin of error is, right? So then.
Wait, the square root of 50 is
7. Isn't 25 times, never mind, you know what I'm doing. Don't do math in your head, Cinnamon, you screwed up. Okay, hold on, what is the square root?
7.071.
Okay, yeah, I should not do. So don't listen to me on the math part, but maybe the formula part I got right.
And what was the z-score?
So the z-score is in that box that it said to memorize, and so the z-score is 1960.
1960?
Yeah.
Point? Anywhere?
1.960.
Okay. Times 400 over 7.071.
So did you get 110?
I got 110.874, yeah.
Okay. So, and I have 8.97. I wonder what I did different.
Oh, so it'd be 111 to round. Oh, wait, but that's not the final answer, is it?
No. So hold on, I think I rounded too soon. 1.96 times 400. I think that's my square root. So I think I need to take more digits. 07106. Okay, so then I got 110.874.
Yep, that's what I got, and then.
Okay, so then go back to this quizzes here. So now that we know what the margin of error is,
Mhm.
we want to know what number will give us 50 hours. So then we go to the formula of n equals that 1.960 times 400, all divided by the m score of 110.874. So this is going to be totally backwards. So, but that's what I'm basing it off of. So my number now is the z-score minus my standard deviation.
Minus, and then all over the,
All over the medium, or the margin of error.
okay. So,
That's weird. That can be right.
why?
Maybe I just did it wrong.
Did you get a negative?
I must have done something wrong. Let me just clear out this.
Why?
I don't know. I got the square root answer, so I'm like, that can't be right. I must have done something wrong.
I got a negative.
So 1.96 times 400, right?
Times.
Divided all of it by, wait. Yeah, like I'm getting 7.071. That can't be right.
I got 7.071.
Yeah, that's what I did too. So if we round it up, it would be 8. We would need 8.
It's so small though.
That's too small. Yeah. That's too small.
Yeah, there's no way.
Okay. Apple company, they know the standard deviation is 400. They want 95% confident interval. The margin error of 50 hours. Back to that lesson again. It's like basically like the last. Okay, so it's like the last equation in the lesson. Oh, we need to square it though. We need to square that answer.
Why?
Because, so here's the one that's similar in the text.
Uh-huh.
And so they gave us, they said, sample size should be larger than this. So it says the number equals z-score times standard deviation divided by the margin of error, and then it's squared.
And then square.
Squared.
So then we would square.
So we always round up the sample size.
And then we get 50.
Okay.
Exactly 50.
So exactly 50. That's. How did they find out that? Okay, in question 12, the process and check. For this question, we use the mean with 2095 confidence. Okay. You have standard deviation. No, I think we did it right. Oh, wait, okay. Instead of squaring it by that z, to go back to the lesson, they took, they want an error of 2000 on either side. So we want an error of 50. So instead of dividing by that score we figured out, 1.960 times 400 divided by 50 and square all of that. I think that's what we're doing. Instead of finding like the interval, we want a total of the answer to be 50. Some type of backwards thing. Let me just look and see if I get that. Okay. I thought I understood this when I was going over it in the book, and I was like, oh, okay, I think I get this. This looks pretty easy. But apparently I don't know. So I have 245.862. You know, they plug theirs in. So we can't have the, so we would have to round up. So 246, and then they plugged it in. The sample size should be larger. It should be larger or smaller than 792. Okay, the sample size should be larger. We want to reduce the margin of error, then we want a larger sample. Okay, so I think it's 246. I think the answer is 246.
Okay.
That's my final answer.
Okay.
All right, the mean salary of actuary is 1,000 and the standard deviation is this. You're interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with level of significance at 0.05. So it's either equal to or not equal to. You collect a simple random sample of 36 women's salaries and find that the mean is 111,000. Use this information for the next 3 questions. Okay. Number 12. How many of these do we have to do? Okay, there's not very many. There's only 14. Okay, what is the lower limit of this 95% confidence interval?
Okay.
Okay. All right, so 46, what is the lower limit? Ugh, I thought I knew what I was doing. Standard deviation, so I know I'm going to be using 36, 730 up here.
So 36 with the
I know that I have a number, so that's got to be the square root of 36, which is down at the bottom. And I want to know what the lower limit of the 95th confidence level is. So I'm going to times that by 1.960. And then I'm going to add it or subtract it from the 111,000. Does that sound right?
I'm lost on this one.
Okay, so I think it's going to go back, kind of like back to that one up above, not recently, but prior. So we're gonna do the n. You're gonna go back to that mean minus z and mean plus z. So basically, we got to find out what that score is. So we got to take our 1.96 z score. We got to multiply it by our standard deviation, which is 36,730. And then we got to divide all of that by the square root of 36 equals, So I have, if I did this right, I'm going to write this number down for 11,998.4667. And if I add that and subtract it from a mean of 11,000, that can't be right. No, that's right. Okay. So then if I go 3 minus 8.46. So I have the low end would be 9,901. 2 would be 9,000.
Yeah, I think that's the answer. That's what I get to.
What is it?
99002.
Yeah.
99,000.
So yeah, $99,002 is the lowest possible in that interval. So it's either going to be that low, or we could add the whatever it is, so the 11,000.
And now we have to add the 11,998.
Yeah.
Right.
How do we add that interval? So like 122.
Yeah, that's what I got. 1, 2, 3, 4, 9, 9, 8.
Oh, a nice little salary margin.
Oh, we have to round one, right? So it'd be 122,999.
Sounds good to me. That's what I would do. If I'm rounding it up, yeah. Okay. 14. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are: simple random sample was drawn from the population. Yes.
That's
We
right.
know that the standard deviation is known. We need to know that the mean is normally distributed. So all of the above.
Yep. Yay.
Okay.
Okay.
Can you help me with? I missed the first couple ones.
Okay. So which one are you on?
3.
Okay.
So
So that's kind of what we just did. So margin of error is 90%.
mhm.
So if we look on that little chart, it's 1.645. And we're just going to plug it into that 4 5. I don't know what the formula is called. I already forgot it. I'm sure it has a name. Sample size formula. Let's see what's the other one called. Well, I don't know what this one's called. Anyways, margin of error. That's what this one is. So we're going to take the 1.645 and we're timesing that by
Standard deviation.
Yeah, divided by 50 with the square root of 25.
So then,
if you need to go, man, you can. Oh, just you good? Okay.
Times 50. We never know when she goes.
I know, she's so quiet.
I know.
I was like, should we wait for him a few more minutes? She's like, I gotta go. And then she just like was real quiet, and I was like, oh, okay, let's start then.
1645.
Yes. So 16.45 is what we got.
Okay.
And then we went down to the next one, 4.
And then that's X is the point estimator.
Yes.
Okay. And then number 5. Is it the same thing?
So it would just be 526. Since we just stated it above, we decided that we're just plugging numbers in now. So the true estimator or the point would be 526.
And then, oh, that's all I needed. Okay.
Okay, so you got number 6.
Yeah, I did.
Okay. All right.
Let's see what we get.
This might have been too bad because she left us.
I know. Let's see.
Oh, I missed something. What did I miss? Okay, the bright light bulb person.
Wait, which one? I got 14 on 14.
I missed 11. What did I put? I don't know what I put, but apparently I didn't type it in correctly.
It's 246.
Oh, I put a comma instead of a point. Oh well, I'll just redo it real quick. I put 2, 469. Is it
It's just 246. That's it.
246?
Mm-hmm.
Okay. All right. So I rounded that out too. Okay. I'm done. I'll just retake it. All right. I'll see you on Thursday.
Okay. Thank you for.
Yeah.
Thanks.
All right.
See ya. Bye.
See you later.